Hello, everybody. So today, last time we discussed about Newton's law and application of Newton's law. Today, I'll discuss application of Newton's law and I will solve one problem. So if you don't know me, my name is Mሥፉን. I work at West Los Angeles College. So it's very important to understand Newton's law because Newton's law gonna help us to solve different problems in physics. So what's Newton's law? So in physics, we have three types of Newton's law. So these Newton's law are very important to solve problems. So Newton's law, Isaac Newton, he coined three physics laws. The first, Newton's law states that a body at rest will remain at rest, and a body that moves with a constant velocity will keep moving at constant velocity if there is no external force acting on it. So if I have this, so this, for example, if I put it like that, it's gonna stay forever unless and otherwise somebody kicked on it. Or if this is moving with a constant velocity, it keeps moving with a constant velocity forever, unless and otherwise an external force acting on it. So this is very important. So, and then just to repeat once more. So if you put this, it's gonna be at rest forever. And if this is moving with constant velocity, it keeps moving with constant velocity unless and otherwise an external force acting on it. So the second law is Newton's second law. So Newton's second law says that a body accelerates if and only if an external force acts on it. That means, look, from physics point of view, we don't discriminate between rest and constant velocity. Because for constant velocity, acceleration is zero. For if an object is at rest, acceleration is also zero. But what happens if you have an object, if you apply a force, it's going to accelerate forever. And then mathematically speaking, so if a net force applied on a system, that system going to accelerate. Okay, that's the meaning. So mathematically speaking, that means sum of the force is equal to mass times acceleration. So and then as you know, the acceleration, yeah, if you apply more force, the acceleration is going to be big. If the mass is big, acceleration is going to be small. So if the force is big, acceleration is going to be big. If the mass is big, the acceleration is going to be small. So sum of the force is equal to mass times acceleration. This is Newton's second law. So in this chapter, we're going to use that. In this discussion, we're going to use Newton's second law to solve a given problem. And then, so the third law is Newton's third law. It says that for any action, there is an equal and opposite force acting. So if you push my hand, for example, if I kick my hand like this with a force F, my hand also kicks back with an equal but opposite forces. So if I kick this down and my hand gonna kick this upward, or if you kick the wall with your hand towards negative x direction, the wall gonna kick you to the positive x direction. So, and then right now I'm sitting down on my chair, I'm applying a force on my chair, and the chair is applying force on me in opposite direction. That's why I'm not falling down. I'm stable because of my action is just I'm sitting on the chair. That's action force, and the normal force which I get it from the table, that is the opposite force. So Newton's third law said that for any action force there is an equal and opposite force. Okay. Now, we're going to use this Newton's law in today's lecture to solve a given problem. But before that, let me discuss about what type of force we have for mechanics in mechanics. So first of all, force has a unit of Newton. Newton is the unit of a force. So when you say a force, you know, we discussed many times force. There are different type of force. So one is weight. So weight is a type of force. And the weight is due to gravity. For example, if I have this is a mass m, and then there is what? Because it's under the influence of gravity, and gravity is pushing it down. So that mass, this mass times gravity, which is 9.8 meter per second square, that's gonna give me the weight. The weight is mass times gravity. So everybody, as long as you have mass on this planet, you have weight. That weight is just the mass of the object times gravity. And the weight is always downward. Be careful. Force is a vector quantity. It has direction and magnitude. So when you put an object like that, that object has a weight. The weight is downwards and is given by mass times gravity. So the m is the mass, g is gravity. Okay. There is another type of force, which is tension. A tension is a force that is transmitted via rope or string. So if you hang an object, like if you hang, for example, this mass, the weight is mass times gravity, it's downward. But because of the string or the rope, there's going to be a tension here, also here and here, because this is rope, and this is rope. There is a tension. This could have, it's going to fall down, but it's not falling down because what? Because of the tension is pushing it up. So tension is the force transmitted via rope or string. Okay. So now we're going to use this to solve problem for today's discussion. And we have another type of force, which is normal force. It's called a ground reaction force. Normal force is a ground reaction force or a contact force. It is perpendicular to the surface. For example, if you put a mass m on the ground, okay, that mass m it's pushing it down with a weight mass times gravity. But it is stable there, it's not moving because the ground is also pushing it back because of Newton's third law. And it's gonna pushing it upward with a normal force. So there is a mg from this small mass. There is a normal force, a ground reaction force in opposite direction. So always normal force is perpendicular to the surface. If you lay on the floor, yes, your mass times gravity, the floor what? Push you up with normal force. And then this normal force is important because normal force is related to friction. So it's a ground reaction force. I told you many times. So when you have a mass m, and then that mass m has mass times gravity, but the ground is also because of Newton third law. There's always reaction force. That's called a normal force. Okay. So far we discussed three types of force: the weight, tension, and normal force. And then we have also friction. And friction, we have two types of friction. So friction is an important force. Okay. And because of friction, you can walk on the floor. Without friction, you cannot walk. Yeah. And friction is important. There are two types of friction. One's kinetic friction. This is a friction due to emotion. And then that's, mathematically speaking, so that's going to be mu k times normal force. Mu k is called coefficient of friction. It's a property of material. It's given for engineering purpose. For example, mu k can be given, like it's known for cement, mu k is known. For wood, mu k is known, but it's a number from 0 to 1, and n is a normal force. Yes, you know how to calculate normal force. I'll show you. And we have also static friction. That's a friction because when the bodies are at rest, and that's when you say static friction, it's going to be coefficient of friction times normal force. So mu s is coefficient of static friction, and n is normal force. So we have two types of friction: kinetic friction and static friction. So these are a type of force that we're gonna use. So in this chapter, we're gonna come up with this force, and we're gonna solve problem. Okay. So let me revise. So we have different type of force. Weight is just mass times gravity. Tension is a force due to what? String or rope. Normal force is a ground reaction force. And then if you put an object, the normal force is upward always. And then we have force of friction. It can be what? Kinetic friction or static friction. But the friction, it depends on the normal force. So, and mu k, it depends from material to material. We have static friction, which is mu s times n, with n is normal force, okay? Now, as I discussed today, we want to use Newton's law. But when you say Newton's second law, we are going to use Newton's second law to solve different problems, okay? As discussed before, Newton's law states that an object accelerates if there is only a net force acting on it. So mathematically speaking, Newton's law says sum of the force is equal to mass times acceleration. But if you are living in 2 dimensions, you have to decompose this into 2. Sum of the force in x direction is going to be mass times acceleration in x direction. Sum of the force in y direction is going to be mass times acceleration in y direction. M is the mass, A is the acceleration. But this is Newton's law for linear motion. Linear motion means motion in one direction, like in x or y direction. But what about if an object is rotating? There will be a torque. So Newton's law, Newton's second law, states that sum of the torque is equal to I times alpha. What is torque? I will come later. Note that torque it has a symbol tau. I is the moment of inertia. Alpha is angular acceleration. Be careful. Force is a vector quantity. Torque is also a vector quantity. It has magnitude and direction. So alpha is also a vector quantity. So when a torque is a vector quantity, and then when an object is moving counterclockwise, it's going to be torque going to be positive. If an object moves clockwise direction, torque going to be negative. What about for a force? For a force, if an object is moving to the positive x-axis, it's going to be positive. If the force is directed to positive x-axis, force is positive. If the force is directed in negative x-axis, force is negative. If a force is directed upward in positive y direction, force is positive. If the force is directed downward, it is negative. But for circular motion, for a torque, counterclockwise, if an object is moving counterclockwise, it is positive. When an object moves clockwise direction, the torque is negative. So this is Newton's second law. So we're going to use this law to solve one particular problem. Very important problem. So this is just application of Newton's second law, okay? Now, what's torque? Torque measures the ability for the force to cause rotation. What does it mean? As I said, mathematically speaking, sum of the torque is equal to I times alpha. I is called moment of inertia. Moment of inertia, we know how to calculate it. Alpha is angular acceleration, okay? So Newton's second law said that. But what's torque? Torque is just, it can be the ability for a force to cause rotation. We call it torque. But what's torque? Torque is force times r times sine theta. This is an object. It's pivot. This is the axis. So this is the rod. We're going to want to rotate like this. So you're going to apply force here. Then F is the force that you applied. R is the distance from the pivot to the location of the force. Theta is the angle between the F and R. Now be careful. So when you say torque measures the ability for the force to cause rotation, means not all forces causes rotation. Not all forces cause rotation. Meaning, for example, if somebody pushes this direction, he cannot rotate because theta is 180. and sine of 180 is 0. Or if somebody push it directly this direction, like this, you cannot rotate it because theta is 0. Because theta, so sine of theta is 0. You can rotate it if you have what? Some angle like this. And then, so the R is very important. If you are far, if the force is going to be big. But if you apply force at the pivot, you cannot rotate because R is 0. That's the meaning. So F times R times sine theta. So this causes what kind of motion? Counterclockwise. Oh, the torque going to be what? The torque going to be positive because the force is this. So this object is rotating counterclockwise. And that force is just, that torque is the force you applied times the R times sine of theta. So this is going to be, so this is what going to use for today's lecture. So solving problem. Now we discuss several concepts right now. So we're going to use them to solve a given problem. So the basic Newton's solving problems using Newton's second law, it's a little bit difficult. And you have to have a strategy. So solving a problem needs your strategy. First, you have to read, draw, label the problems. And then you have to draw a free body diagram. I will show you for each body. And then you have to label the X and Y component along X and Y direction and apply Newton's law for each body diagram and solve the unknown quantity. Now, look, you cannot learn physics without practicing problem. You have to practice a lot of problem. Now, today's lecture is very important from my point of view because here I gave you a very good example. So just a general example. So I have a block mass 1, which is 1 kilogram, as shown on the top of the table. So this table, the coefficient of static friction between the block and the table is 0.1. There is a force of friction here, and mu k is just 0.1. Block 1 is attached to block 2, and block 2 has a mass of 4 kilograms. So this is 1 kilogram, block 2 is 4 kilograms. And then I have a pulley. Oh, I have a pulley. Sorry, the typo. So no, there's a, so the cord is negligible mass. Yes, that's good. And the pulley has a mass of 1 kilogram. So I have a mass. This pulley has a mass of 1 kilogram. M1 is 1 kilogram. M2 is 4 kilogram. And then there is force of friction. So imagine, because M2 is bigger, 4 kilogram, what's going to happen? It's going to what? Push M1. And M1, because of gravity, M2 is going down because of the gravity, the weight. M2 is heavier than M1, so it can push down, and then M1 is going that direction, and M2 is going to that direction. And this pulley is rotating which way? Clockwise direction. So this problem is a little bit different problem, but I'm not directly solving it. I'll systematically solve by taking different cases so that you can have a basic understanding. Let me repeat the problem. So I have a mass 1, which is 1 kilogram. I have mass 2, which is 4 kilogram. I have a pulley, which is 1 kilogram. And then there is a coefficient of friction here. And then this is under the influence of gravity, and M2 is going down. And then because of that, M1 is going to the right, M2 is going down. Now, I will not directly solve this first. Look, what can I do? First, the same problem, the same setup, but let me assume, guys, let me assume there is no friction and the pulley is massless. So first, the same problem, but let me take it easy. So no friction here, and the pulley is massless. Of course, now what's going to happen? So there is, the pulley is massless and there is no friction here. So let me solve that problem first. Then, but this is 1 kilogram as before. M2 is 4 kilogram as before. And T, now what kind of force I experience? Now, because of the string, I have tension. I told you if you have a string, and then this is tension. We have also tension because of the string or because of the rope. Because the pulley is massless, remember, tension here, it's going to be the same as here. So because the pulley is massless, tension here, this is the same as tension here. Now, let me repeat one more time. The same problem I'm solving, but now I assume no friction and the pulley is massless. And massless pulley means tension here is the same as tension here. Okay. What can I do to solve such kind of problem? What can I do to solve such kind of problem? First, you have to have a free body diagram. How many bodies I have? Oh, I have two objects, M1 and M2. Okay. Oh, M1 is going to the right. Acceleration is vector quantity. A is positive. Okay. So name all the force. So this is a free body diagram for M1. And then I name all the forces. Oh, there is a contact force because the table is pushing it up. I call it normal force. And because the mass one is under the influence of gravity, there is a weight. Weight is always downward, M1G. And the object is going this way. Oh, that means acceleration is this way. And tension is also this way. Okay? So I write the free body diagram. So because why M1 is going that direction? Because the tension is pushing it that direction. Okay? And then I write Newton's law. I don't need Newton's law in y direction for now. Newton's law for in x direction, sum of the force is equal to mass 1 times acceleration. Now look, mass acceleration is positive because the object is going to the right. I put it positive. Okay. So how many force I have in x direction? Only tension. Oh, tension is equal to M1A. That's it. Now remember, the pulley is massless, so tension here is the same as tension here. For M2, life is simple. So M2 is going down because gravity, M2G, the weight. And then it's not what? Free falling. Like, why? Because the tension is saying, is what? Pushing it upward. It's opposing. So the tension, the mass 2 want to fall freely, but mass 2 cannot do that. Why? Because the tension is pushing it up. Okay. So, and then M2 is going down, so acceleration is negative. So sum of the force in y direction is negative M2A. Okay. Oh, then tension minus, because you have to add all the force. T is positive, M2 is negative, is equal to M2A. You take this one to the right, it's going to change. When it passes equality, it's going to be positive. So tension is equal to minus M2A plus M2G. Good. So I have one tension here and another tension. So from this free body diagram, I got this. From this free body diagram, I got this. But since the pulley is massless, tension is equal to tension. Oh, I get one tension, which is M1A from here. The other tension is here. They are equal, M2A plus M2G. Now collect the same terms. Take M2A to that. When it passes equality, going to be positive. So M1 plus M2 times A is equal to M2G. Divide by M1 plus M2, divide by M1 plus M2. So I got the acceleration, which is M2G over M1 plus M2. You see? So the acceleration is going to be big when M2 is big. Yes? And it's not free fall. If M1 is 0, believe it or not, this is 0, M2 cancel. M2 acceleration will be gravity. That's going to be free fall. That's not free fall now because M2 is what it says. It's restricting M2 not to move fast. So acceleration is going to be m2g over m1 plus m2. What about tension? Oh, once you find the acceleration, you can substitute here or here. You'll get the same answer. I choose this. You'll get the same answer. So tension is m1a. So m1, but the acceleration is m2g over m1 plus m2. Just plug it. So tension going to be m1 times m2 times g over m1 plus m2. So that's going to be the tension. Okay. Now, guys, once you understand this, so I found the acceleration, the tension. But let me make it a little bit difficult. Let me add friction now. The pulley is massless, but let me add friction. The same problem, but this is 1 kilogram, m2 is 4 kilogram, and then the pulley is massless, but if there is a coefficient of friction, if there is a friction between the m1 and m this. In the previous example, there was no friction. Now let me add friction. What happened? Yes, friction opposes the motion. So m2 is heavy, it's gonna push it, it's gonna fall down, m1 will go to the right. But because there is a friction, it slow down, and the friction is in opposite direction. What kind of friction? Kinetic friction. Why? Because m1 is moving. So now, what's friction? What's friction? By definition, mu k times n. What's mu k? Mu k is 0.1. What's normal force? We're gonna find that. Now we have additional force. What's that additional force? Friction. It is in opposite direction. So, but the pulley is still massless. Since the pulley is massless, tension is equal to tension. But m1 is going to the right, m2 is going down, and we want to solve this problem. What can I do, guys? What can I do? Yes, a free body diagram. Let me repeat one more time. M1 is 1 kilogram, M2 is 4 kilogram, but now I added friction to the previous problem. When you add friction, this is going to be slowed down. We're going to check it out, okay? And then a friction is always opposite motion, okay? So you have to have a free body diagram. Oh, now it's a little bit difficult. So M1, if you take M1, there is a normal force, always normal force because of the table pushing it up, there is normal force. M1 is under the influence of gravity. M1g is the weight, which is downward. Oh, why is moving this way? Because tension is pushing it that direction. But friction, say, opposes the motion. So it's going to be that direction. Okay? Mu k. So mu k times normal force. Now, this is my free body diagram. The normal force, tension is pushing that direction, friction is pushing that direction, and M1 is that direction. Now, I can use Newton's law, but this time I'm going to use Newton's law in y direction. So Newton's law in y direction is 0. Why? Why? Because M1 is not moving in y direction. It's always on the table. Oh, there is no acceleration in y direction. Okay, 0. Oh, but in y direction, I have normal force, which is positive because force is a vector. Up is positive, down is negative. Plus m1 is negative, is equal to 0. So take m1g towards the right. So normal force is equal to m1g. Okay, that's good. But in x direction, the system does accelerate. It accelerates. So sum of the force in x direction is m1 times a. Okay? And a force in x direction, oh, tension is pushing that direction. Friction opposes the motion. It's negative x direction, so negative k, negative fk is equal to m1a. Why? Because acceleration is positive. So this is positive all the time. Okay? And fk, by definition, fk is mu k times normal force. I write it here. So, but normal force is m1g. Put this in here. So t minus mk times n is equal to m1a. So t, now, you see, from here, I just t, but fk is mu k times n, just like that, is equal to m1a. So I substitute this in here and I rewrite it here, and then take this to the right. So m1a plus mu k, but normal force is just m1g. Just I plug it. So tension is m1a plus mu k times m1g. That's the tension. Is that clear? It's not clear, right? So tension minus mu k times n is equal to m1a. This is from here, but normal force is m1g. Can plug it here and take it to the right, and I get that. For m2, I have m2g. It's the same as before. I have tension, so m2g is pushing it downward, but it's not free falling because the tension is opposing always. So in that direction, and m2 is going to negative y direction. So that acceleration is negative. So sum of the force in y direction is negative m to a. Why negative? Because acceleration is negative. Oh, sum of the force in y direction, tension is positive because upward. This force is positive in positive y direction. M to G is negative. Why negative? Because it's going down. So it's downwards. No, it's because the force is downwards. So T minus M to G is equal to minus M to A. Why minus? Because this is negative, because downward. Tension is positive because up is equal to M minus M to A. So tension is equal to minus M to A plus M to G. But now I'm lucky because the pulley is massless. Or if the pulley is massless, tension here is equal to tension here. Okay? So that means this tension is the same as this tension. So put this tension here, M1A plus mu K M1G is equal to tension here, minus M2A plus M2G. Now I collect the same terms. So let me collect the acceleration terms in the right direction and the gravity terms in left direction. When this pass equality, because it was negative, now it's going to be positive. I take it out. This is positive, it's going to be negative. So, and then I take common because M1 acceleration is common. So it's going to be acceleration is going to be M to G minus mu K M1G over M1 plus M2. You see, now the acceleration is less than before. You see, in my previous example, this was not present. This part was not present. Now it's gonna what? Subtract means friction is a little bit lower. Okay, is that clear? So tension is equal to tension. One tension, I get it from this free body diagram. I bring it here. The other tension is here. Tension is the same here, is the same as here. So, and then I collect the same terms, acceleration terms in the right side, the gravity terms in the left, and then I take the common, and then I found the acceleration. Is that good? Now, the final example. Let me add a mass to the pulley. Now it's going to be very difficult. Why? Because the friction, we have a friction, and the pulley has a mass. When a pulley has a mass, means there is moment of inertia. Moment of inertia means it's going to resist. Oh, then the acceleration become even smaller because one from the friction. The other one is from moment of inertia here, from the inertia here, because the moment there is what? Resistance, there is inertia because the pulley has mass. And then because of the pulley has mass, tension will never be the same now. Tension here will never be the same as tension here. So this is going to be T1, this is going to be T2. Of course, the whole system will have the same acceleration because they are connected with the string. And M1 is going to the right, and M1 is going to the right, and M2 is going down. So now we have three free body diagram because the pulley has mass now. So you have to have three free body diagram to solve this problem. Now the acceleration is going to be more, even smaller, because you have resistance, you have the friction term going to slow down, and because the pulley has a mass, it's going to resist also. Okay, And then what can I do now to solve this problem? Okay, now the same problem. Okay, M1. Okay, we have normal force as before because there is a ground force. The table is pushing the up direction. There is M1G pushing it down direction. Oh, the system is going to the right. So why is going to the right? Because of tension is pushing it. But friction is always on opposite direction because there is force of friction between M1 and the table. And then that's mu k times N, where N is normal force, mu k is coefficient of friction. That's it. So we have tension. So sum of the force in y direction is 0. Why? Because it's not accelerating in y direction. So, and then this implies you have to sum all the forces. How many forces I have in y direction? Normal force and M1G. Oh, normal force is positive. M1G is negative because minus M1G. Negative because downward is 0. Normal force is called to M1G. Once you find normal force, you can plug it here and you can find force of friction. Oh, sum of the force in x direction is M1A. Why? Is because acceleration is positive. This should be also positive. Sum of the force in x direction. How many forces have in x direction? One is tension. The other one is mu k times normal force. So tension minus Fk, or force of friction, is equal to M1A. Fk is mu k times normal force. Normal force is M1G. You can plug it here and then plug it here. Okay. So T1 minus mu k n is equal to M1A. So T1 is equal to M1A. When this pass equality, it's going to be positive mk, but instead of normal force, I can put M1G. So this is my tension one. I got it from the first free body diagram. It's similar to before. It's going to be M1A plus mk times M1G. So what can I do now? Believe it or not, now we have a pulley. The pulley here, that pulley is rotating. It has mass. It has inertia. Okay, so now it has moment of inertia. And then Newton's law says that sum of the torque is equal to negative I times alpha. Wait, why I make it negative? Because angular acceleration is a vector quantity. It has magnitude and direction. So if you are moving clockwise direction, and if you are speeding, alpha is negative. Because you are moving clockwise direction. So the whole system is moving what? Clockwise. Effectively, it's moving clockwise direction because when M1 goes this direction, when M goes this direction, the pulley is rotating clockwise direction. And the angular acceleration is negative. And then sum of the torque. So, and angular acceleration is the linear acceleration divided by the radius of the pulley that we learned it before. And then sum of the torque means, torque is a product of force times R times sine of theta. I discussed it in the third PowerPoint slides. So torque is force times radius times sine theta. Now, force is what? T1 times R times sine of 90. So sine of 90 is 1. So, why T1 R is positive? Because T1 causes counterclockwise motion. So T1, what? If without T2, this could have rotated counterclockwise direction. So T1 is what? T1 times R is positive. Yes? Because torque is positive for counterclockwise direction. T2 alone without T1, it causes clockwise direction. The torque is force times R times sine of 90. I don't care. Sine of 90 is just 1. So T2 times R. So T2 is the torque. So T2 times R is the torque. But why negative? Because T2, this force causes clockwise motion. and then divide this by r, the whole thing. You cannot. If you divide this by r, you have to divide this by r. So T1 r minus T2 r is equal to minus I times alpha is A over r. Just put A over r here. And then divide this by r, divide by r. T1 minus T2 is equal to negative I times A over r squared. That's it. So I is called moment of inertia. Moment of inertia, it depends on the shape of the system, and then depend on the rotational axis and so on. So, and moment of inertia is, I'll show you later, okay? So, and then for the M2, for this M2 is going down, M2G is down, T2 is pushing it up because M2G want to go freely, but it cannot go freely because T2 is pushing it upward. And the acceleration is negative because M2 is going down. Some of the force in y direction is negative m to a, y negative because acceleration is negative. And then some of the force means T2 is positive, m to g is just negative, is equal to minus m to a. So T2 gonna be minus m to a plus m to g. Okay, so take this to opposite direction, it can be negative m to a plus m to g. Now I have T1 here from the first free body diagram. I have another free body diagram from the pulley. I have another free body diagram from the M2. And then now take this, T1 minus T2 is negative I times A over R squared. Yes? Now, bring it here. T1 minus T2 is equal to minus I A over R squared. Good. But T1 is this. Plug this T1 here. T1, plug this here. T1 minus T2. But minus of minus, it makes plus. But minus of this is going to be minus m to g. So I plug T1 here. I plug T2 here. And I got that is equal to negative I A over R squared. Now collect similar terms, all acceleration terms to the left, all gravity terms to the right. Okay, so when I can just, this was negative. When I bring it to the right, it becomes positive. So m1a plus m2a, I bring it here, I times a over r squared is equal to, this was negative. When past equality, it's going to be m to g positive, and minus this mu k m1g. G is common for both of them. You can factor it out or whatever. Okay, so here a is common, so m1 plus m2 plus I over r squared times a is equal to m to g minus mu k m1g. Divide this, divide by that, and acceleration divide by this term over m1 plus m2 plus I over r squared. Divide this. Acceleration going to be g, I take it common, m2 minus mu k m1 over m1 plus m2 plus I over r squared. Now, I is called moment of inertia. If the pulley is disk, it can be sphere, whatever. So for a disk, moment of inertia is mr squared over 2, where m is the mass of the pulley, r is the radius of the pulley over 2. So plug this in here, so you get g m2 minus mu k times m1 over m1 plus m2 plus m over 2. Now this acceleration, you see, we have this term, additional term, this term and this term, you see. So now the acceleration becomes even smaller because now you have a friction, and now you have what? Moment of inertia. The inertia gonna resist the motion. Okay, so I'm just discussing in a simple language. So now I get the acceleration for the 3 cases. Okay, so remember, first I start my problem without friction when a pulley is massless. Then in the second example, let me add friction, but the pulley is massless. On the third example, let me add the pulley with a mass m, and let me add friction to it. Or another way of speaking, So my question, my original question, I took M2 to be 4 kilogram, M1 to be 1 kilogram, gravity is 9.8 meters per second squared, a pulley is 1 kilogram mass, Mk is moment of inertia, which is 0.1. Okay, that's good. Now, I solved the problem for 3 cases. Now, as you say in this lecture, I solved the problem. So, in the absence of friction, and when the pulley is massless, I got this in the first discussion, yes. And M2 is 4 kilogram, gravity is 9.8, M1 is 1 kilogram, M2 is 4 kilogram. If you do the algebra, it's going to be 7.84 meters per second squared. Now, in the presence of friction, but when the pulley is massless, look, M2 minus Mk M1 times G over M1 plus M2. Look, compare this and this. Now, in addition this, you have this term. M2 is M2, G is G, M1, M2, M1, M2. But this term is new. Why? Because this is because of friction. So you have subtracting M2 this. So A2 going to be small. This A going to be small because the friction term makes this term smaller. So plug the value of M2, plug the value of Mk, plug the value of M1, plug the value of gravity, plug the value of M1 and M2, and do the algebra is 7.644 meters per second squared. Look, this was 7.84. Now it becomes 7.644. Acceleration becomes smaller now. And then, so I'm revising the whole one. I'm revising the whole my discussion. So, and then when I solve the problem in the presence of friction, and when the pulley has mass M, now look, M2 is M2, Mk is Mk, M1 is M1, G is G. Look, M1, M1, M2 is also M2 here, but M over 2 is additional. So this makes even this acceleration smaller because you have additional term because of from a pulley. This is from the pulley. So when the pulley has a mass, and if you have friction, the acceleration becomes even more smaller. So M2 is just 4 kilogram, Mk is 0.1, M1 is 1 kilogram, gravity is 9.8, M1, the 1 kilogram, M2, 4 kilogram. The pulley is 1 kilogram, 1 over 2 kilogram. So 1 divided by 2 is just 0.5. And do the algebra. You get 6.94909 meters per second squared. So everything, look, compare. So I'm advising you to compare the 3 acceleration. So this acceleration, and this acceleration. So this is going to help us because most of my students are going to be confused because when a pulley has mass, you know, the acceleration is going to be smaller. Why? Because of what? Moment of inertia. No, because of the inertia. So the pulley going to resist the motion. So now I solved the problem for 3 different cases. And then when the acceleration when I add friction, it becomes smaller. But when I add friction and when I add mass to the pulley, it becomes even smaller. So you have to solve different problem like that. You can use inclined plane, whatever different question. The method which I discussed today, it's going to help you. Please do a lot of problems to understand physics. So this is just one simple problem. Then go to your book and solve different problem. And that's going to be today's lecture. And then whenever you have any problem, just contact me.